Hello friends, today we will discuss the important topic, that is laws of chemical combination. Laws of chemical combination. If you see, many things are happening around us. Some are physical changes, some are chemical changes. Particularly, chemical changes means combination of reactants forming product. This combination generally occurs between the reactants and forming the products. It follow some principles, laws, that is called laws of chemical combination. All combination, all reactions follow this principle, laws of chemical combination. Some physical changes also obey this law. Let us discuss some important laws of chemical combination. The first law, that is called law of conservation of mass. Law of conservation of mass. This law was stated by Antony Lavoisier. Stated by Antony Lavoisier. This law was stated by Antony Lavoisier. What is the statement of this law? That mass can neither be created, mass can neither be created nor be destroyed in any physical or chemical changes. What is this? Mass can neither be created nor be destroyed in any physical or chemical changes. That means mass of the reactant is equal to mass of product. This is the basic principle of law of conservation of mass. Mass of the reactant is equal to mass of product. Mass of reactant means that you have taken and that you have got, that is the mass of product. Both amount, both mass remain same. That is called law of conservation of mass. And this principle is used what? To balance the chemical equation. This principle is used to balance the chemical equation in both sides. Left side and right side, total mass remaining same means total atoms in the left side is equal to total atoms in the right side. That's why all chemical change follow the law of conservation of mass. Suppose let potassium iodide aqueous means solution of potassium iodide in water reacts with lead nitrate aqueous means water soluble produce. You see the reaction, the product is potassium nitrate aqueous plus lead iodide. This is solid and this is aqueous. All this first solution, second solution is aqueous, forming third solution, that is potassium nitrate, which is water soluble, but lead iodide which is produced, that is water insoluble, observed as a solid mass. If its weight, Ki weight, suppose W 1 gram, and this is your W 2 gram, you take the amount of potassium iodide solution is W 1 gram and the lead nitrate solution is W 2 gram. It is known. When you mix, you see the observation. This is your potassium, this is your lead nitrate. Both solutions are colorless. Water soluble, the substance is potassium iodide and lead nitrate. This is potassium iodide, this is lead nitrate. Both are colorless, just like water. Here potassium iodide is W 1 gram, its weight is known, and lead nitrate, that is W 2 gram, its mass is known. When you mix, here the observation is a chemical change. It is a chemical change because here potassium iodide and lead nitrate reacts forming potassium nitrate and PbI2. Here both are in aqueous. This resulting solution is also contain water and this solution contains potassium nitrate. But the yellow mass obtained, now it is getting settling down. Slowly it is settling at the bottom of the container. That's why this yellow mass is lead iodide. This yellow mass is lead iodide. This mass is lead iodide. It will be settled down after some time. So, if you take the weight after mixing W 1 gram, W 2 gram, if you take this mixture of two solutions, and if you take the weight will be W1 plus W2 gram. Whole solution weight will be W1 plus W2. That means what? Mass of the reactant will be equal to mass of product. It is experimentally already proved that any change, maybe a physical change or chemical change, what? The mass of reactant always equal to mass of product. Suppose one question. X gram carbon bonds in oxygen forming Y gram carbon dioxide. X gram carbon bonds in oxygen forming Y gram carbon dioxide. amount of carbon dioxide produced is given. What is the reaction? C plus O2 on heating producing CO2. Here mass of carbon is X gram, mass of carbon dioxide produced is Y gram. Question is how much of oxygen combined? How much? What is the mass of oxygen? That is question mark. What is the mass of oxygen combined with carbon? We will apply law of conservation of mass. What is law of conservation of mass? Mass of reactant is equal to mass of product. Here X. Here mass of reactant is carbon is X. Let the mass of oxygen is suppose W is equal to mass of product. Here mass of product is carbon dioxide Y. Then what is the mass of W? W is equal to Y minus X. So any problem when you want to justify the law of conservation of mass, you have to know the mass of reactant and what are the mass of product. Then you can compare how you can calculate the amount of product produced or amount of reactant combined from the equation. So like this we can prove the law of conservation of mass. Then come to second law of combination. Second law, that is law of constant proportion. Law of constant proportion. Law of constant proportion. And this law is stated by J.L. Proust. Sometimes question is also asking in competitive examination, who stated law of constant proportion? Constant proportion, or it is called definite proportion. Definite means fixed, by J.L. Proust. What is the law? Compound is made up of two or more elements. Compound is made up of two or more elements in a fixed ratio by weight. This law is also called as the definition of compound. This law also satisfies the definition of compound. Compound is made of two or more elements in a fixed ratio by weight. For example, water. In water, H2O, the mass of hydrogen taken as, for 2 hydrogen taken as 2 and 1 oxygen mass is taken as 16. Comparative mass, relative mass of oxygen is 16 and for 2 hydrogen is 2. Then the value is 1 is to 8. You can collect water from different sources. The percentage of hydrogen, oxygen in water is fixed. It cannot be changed. Percentage of hydrogen, oxygen in water is always constant, always fixed. That is called the law of constant proportion. You take carbon dioxide. Carbon is The relative mass of carbon is 12 and relative mass of oxygen, 2 oxygen is 32. That is your 4:8. Sorry. That is your 3:8. That is 3:8. This is the ratio of carbon and oxygen in what? Carbon dioxide. It is constant. It is constant. For CO2 it is constant. For water it is constant. That is called law of conservation of mass. Sorry, law of constant proportion. This law of constant proportion can be experimentally proved. It is proved experimentally. Let us discuss one problem. What is that law? In an experiment, 6.488 gram of lead combined with 1.002 gram oxygen forming lead peroxide. In the experiment, 6.48 gram of lead combined with 1.002 gram oxygen forming lead oxide. This is the first part. This is the first experiment. In the second experiment, when lead nitrate heated, it gives lead peroxide. In the second experiment, in the first experiment, there is a combination of lead and oxygen forming lead peroxide by heating. This is the first experiment. This much of lead combined with this much of oxygen forming lead oxide. In the second experiment, lead oxide can be obtained by the heating of lead nitrate. Same lead oxide can be obtained by heating lead nitrate. And in the second experiment, it is calculated that the percentage of oxygen in PbO2, in the second experiment, it is calculated. The percentage of oxygen in PbO2 is 13.38. Is 13.38. In the second experiment, you see carefully. In the first experiment, lead peroxide is produced by heating of lead and oxygen. By taking the mixture of lead and oxygen, when it gets heated, it produces PbO2. And how much lead is combined, how much oxygen is combined is given. But in the second experiment, just different. What the experiment? Lead oxide can be produced in another way. How? By heating lead nitrate. And in the second experiment, it is observed that, as per the question, the percentage of oxygen in PbO2 is 13.38. In the second experiment, percentage of oxygen is given. Now, in the first experiment, we will prove what is the percentage of oxygen in PbO2. In the first experiment also produced PbO2 and second experiment also produced PbO2. In this, both PbO2 is same. Now we will compare whether it is same or different by comparing the percentage of oxygen. Now we calculate the percentage of oxygen in the first, because in the second already given. So in the first, the percentage oxygen. So Okay. 1.00. Okay. Here total mass of PbO2 in the first experiment. How much? Pb is 6.488 plus 1.002. What is the total value? Total value is how much? You calculate. That is 0.947. Okay. Okay, so 7.490 gram. This is the weight of PbO2. This is the weight of PbO2. Now we will apply 7.490 gram PbO2 contain how much oxygen? 1.002 gram oxygen as per the question. By combining we got this much. So this much of PbO2 contain this much of oxygen as per the question. So 1 gram will be how much? 1.002 by 7.490 grams. Then 100 gram will be how much? 100 gram of PbO2 contain how much? 1.002 upon 7.490 into 100. If you calculate, the result will be how much? 13.38%. 13.3%. That means in the first experiment, the percentage of oxygen in PbO2 is 13.38%. In the second experiment, the oxygen percent in PbO2 is 13.33. That means both percentage, that is the composition of oxygen, the composition of PbO2 is same in the first experiment and second experiment. That means this compound illustrate, or this experiment illustrate or is explaining the law of constant proportion, because the element ratio is constant in the first experiment and also in the second experiment. That's why it is the example of law of constant proportion. Then third law is law of multiple proportion. Law of multiple proportion. This law was stated by Johann Dalton. This law was stated by Johann Dalton. What is the statement of this law? What are the principle behind this law? This law states that two elements combine to form two or more compounds. Two elements combine to form two or more compounds. Then the ratio of one element in the ratio of one element combine with the fixed mass of other two elements combine to form two or more compounds, then the ratio of one element combined with fixed mass of other will be a simple one. Means simple ratio. You read again. Two elements combine to form two or more compounds, then the ratio of one element combined with the fixed mass of other will be a simple one. What does mean? This states that suppose you take carbon, combine with oxygen, produce carbon dioxide on heating. Carbon reacts with oxygen, produce carbon monoxide. Possible? Carbon reacts with oxygen, forming carbon dioxide. Carbon reacts with oxygen, forming carbon monoxide. It is possible. Both are possible. It is complete combustion. It is incomplete combustion. So you see the ratio of carbon and oxygen. Here one carbon, the relative mass is 12, and 2 oxygen, the relative mass is 32. Then in CO2, the relative mass of carbon is 12, and for one oxygen that is 16. Now first compound, second compound is produced by the combination of two elements, one and second. Two elements combined, here element is carbon and oxygen, to form two compounds. One is carbon dioxide, another is carbon monoxide. Then we will calculate the ratio of one element. Here the ratio we take oxygen, and keeping carbon constant, we have to take a fixed mass. Let the fixed mass is carbon, because 12 is constant. Now you take the different weight. Here different weight is, one is 16, another is 32. So what is the value? Ratio 32:16. Because one is constant, we have to take the fixed mass. Here fixed mass is carbon. What is the different mass? 32 and 16. Which? That is oxygen. So 32 and 16, that is 2:1. 2:1 is a simple ratio, because it cannot be simplified. It is already a simple ratio, 2:1. Simple ratio means which has no common factor. 2:1. Again 2:1. That's why it satisfies the law of multiple proportion. When two elements, here two elements is carbon and oxygen, combine to form two or more compounds. Here taken two compounds. Two compounds are CO2 and CO after combination. And the percentage of oxygen in the both is how much? 32 and 16. Keeping carbon is constant, then the ratio of oxygen in the two compound is 2:1, which is a simple one. That's why it is satisfying the what? Law of multiple proportion. Let us discuss the problem. What is the problem? The problem data is, in oxides of carbon, in the first experiment, oxides of carbon contain, the carbon percentage is 42.9, and oxygen percentage is 57.1. Because 100 minus this, it will be give this result. Then in the second experiment, carbon percentage is in the second oxide, the first oxide, then second oxide, The carbon percentage is 27.3%. And oxygen percentage remaining how much? 72.7%. This in the first experiment, the carbon percent this much, oxygen percent this much. In the second experiment, carbon percent is this much and oxygen percent this much. We'll compare this experiment to whether it is satisfying law of multiple proportion or not. What is the law of multiple proportion? We have to take one mass constant. So you take oxygen mass is constant. You take the oxygen mass is constant. That means you take carbon oxygen ratio. So in the first experiment, the carbon and oxygen ratio is how much? 42.9 upon 57.1. This ratio is how much? 0.751. 0.751. Here this indicate the oxygen mass is 1 because carbon to oxygen division means per gram of oxygen we are calculating. When you are dividing X by Y means per Y gram. For 1 gram of Y, how much the value? Here is said for 1 gram of oxygen, what is the value? For 1 gram of oxygen, the ratio is this much. In the second experiment, carbon oxygen ratio how much? That is how much? 27.3 upon 72.7. 72.7. The value is how much? You can do it. You do fastly. The answer will be 0.376. 0.376. So this is the ratio of carbon oxygen in the first compound. In the second compound, the carbon oxygen ratio is this much. That means here which part is constant? Here oxygen is constant. Because carbon to oxygen divide means we are keeping oxygen 1. Here carbon to oxygen means we are keeping oxygen is 1. That means this is the relative mass of carbon and this is the relative mass of carbon compared to oxygen. The value of carbon with respect to oxygen is this much. The value of carbon with respect to oxygen is this much. Clear? Then you compare this value. You divide this first carbon value with second carbon value. So carbon ratio in the first experiment, then in the second experiment is 0.751 upon 0.376. It is approximately 2:1 because it is 2 times, approximately 2 times. So it is satisfying the law of multiple proportion. What is law of multiple proportion? If one mass is constant, the different mass ratio will be a simple one. So the different mass is here carbon. Carbon is this much in the first experiment. Carbon is this much in the second experiment. Keeping the oxygen mass is constant. That's why the mass of both different mass, when it will be taken, this ratio will be 2:1, coming 2:1. That's why it is a simple ratio, satisfying the law. This is the third law. Then come to fourth law. Fourth law is law of reciprocal proportion. Fourth law states, the law is called law of reciprocal proportion. This law stated by Richard. Scientist name is Richard. He stated this law. This law is somewhat complicated. The statement is somewhat bigger. but very easy to understand. The law states that ratio of different mass of two elements, ratio of different mass of two elements combine with fixed mass of third element will be same or simple multiple, same or simple multiple when they combine each other. Statement is, when you read it will be just confused, but when you take the examples it will be very easy. Ratio of different mass of two elements combined with fixed mass. That means law is stating that one mass should be fixed. With the third element mass should be fixed. Then this ratio will be same or simple multiple when these two elements combine each other. For example, you take three elements. As per the law, three elements taken. Suppose it is hydrogen, this is oxygen, this is sulfur. Three elements. Hydrogen, oxygen combine, produce water. Then hydrogen, sulfur combine, H2S. Possible? When hydrogen combine with oxygen, produce water. When hydrogen combine with sulfur, produce H2S. You see the law. Ratio of different mass of two elements. Here two elements is which one? Sulfur and oxygen. This is the differ. Combine with the fixed mass of third element taken as hydrogen. Let you take hydrogen third. You take two elements, sulfur and oxygen. You combine sulfur with hydrogen, combine oxygen with hydrogen. The law is stating that ratio of different mass of two elements. Suppose here sulfur combined with hydrogen, that is H2S. And oxygen second element with the third element is water. Now you take the fixed mass. One element mass is fixed. Here let the mass is hydrogen is common. The common element mass will be taken constant. Here the common is hydrogen. So here relative mass is 2:32. Here relative mass is 2:16. Which mass is constant? Here hydrogen taken constant. Then different mass is, what is the different mass? 16:32. How much? 1:2. This is the ratio of what? Oxygen and sulfur. This is the ratio of oxygen with sulfur. Oxygen is 16 and sulfur is 32. Keeping constant weight is hydrogen. As per the law, one mass should be fixed, constant. Constant will be neglected. Then what are the different weight? 16 and 32. The ratio is 1:2. Then the laws, again second part of the law is when they combine each other, produce sulfur dioxide. And what is the ratio of sulfur dioxide? Ratio of sulfur and oxygen. Sulfur oxygen ratio is sulfur relative mass is 32. 2 oxygen relative mass is 32. 2 oxygen relative mass will be 32. 1 sulfur relative mass is 32. What is the value? That is now sulfur oxygen taken. That is sulfur and oxygen ratio is 1:1 because 30 to 30 to 1:1. That means oxygen and sulfur ratio is same 1:1. Sulfur oxygen, oxygen sulfur, because we have taken oxygen sulfur. Now oxygen sulfur is 1:2 in the first comparison. When they combine each, the ratio of sulfur oxygen is oxygen sulfur is 1:1. You take this ratio 1:2 and 1:1 is equal to 1:2. Which is a simple one, not same. It is a simple one. 1:2 is simple ratio. Either same or simple multiple. Either same or simple multiple. Here 1:2 is coming, here 1:1. It is not the same. When it will be 1:2, then this ratio is same. But this ratio is not same. These two ratio is a simple multiple. 1:2 will come. You divide these two ratio, you will get another ratio. This ratio is, if the ratio is 1, that is same. If ratio is some multiple value, then it is simple multiple. So this is regarding the law of reciprocal proportion. Then let us discuss problem. The reciprocal problem is like this. You take how many compounds? You have to take 3 compounds. Here is water, H2S, SO2. Here are how many elements? 3 elements. Sulfur, oxygen, hydrogen. We have to take one element constant. Here one element is hydrogen taken is constant. Similarly, the data is problem data. The problem is like this. Ammonia, it is a compound of hydrogen, nitrogen. The percentage of nitrogen percentage is how much? 82.35. 82.35 ratio. Then hydrogen ratio how much? Remaining 100 minus this much. How much? 17.65. 17.65. Okay. Sometimes question one percentage given, other percentage will not given. For other percentage you have to calculate by deducting from 100. Very important. Then ammonia is given. Second compound is water. Ammonia, then water. Here which is common? Hydrogen is common. One should be constant. Here hydrogen will be taken as constant. Then hydrogen oxygen ratio, suppose you take your oxygen percentage oxygen in the water is 88.40. 88.4 90, that is 90. Then hydrogen percent in water is 11.1. Okay, so this is the percentage of oxygen and hydrogen in the set. Then as per the rule, which will be taken constant? Hydrogen will be taken constant. Now you take NH ratio. NH ratio. How much? 82 upon 35. 82.35. 35 upon 17.65. What is the NH ratio? NH ratio is how much? NH ratio is 4.67. It will be 4.67. That means nitrogen to hydrogen ratio is this much in compared to hydrogen taken 1. N by H means hydrogen mass is taken as 1. What is the second? Oxygen and hydrogen ratio. Oxygen is 88.90 upon hydrogen is 11.1. What is the value? OH value, OH ratio. OH ratio is 8.01. The answer will be 8.01. So this is the NH ratio, this is the OH ratio, keeping hydrogen constant. Because we are dividing hydrogen means per gram. We are dividing hydrogen means per gram. That means hydrogen is constant. Then what is the amount of nitrogen? This is the amount of nitrogen per gram of hydrogen. this is the amount of oxygen per gram of hydrogen. Then you take this ratio, N and O ratio. So now N and O ratio is how much? By taking this, how much? N is 467 divided by 8.01. How much result? NO value is 1, that will be 1.171. 1 point, answer is, if you divide, it will be, that means 1 point or 1 is to 1.171. It is smaller, it is greater. So this is the percentage of nitrogen with respect to 1 gram oxygen. Then in the last, another experiment given, then when nitrogen and oxygen combine, this is obtained from these two data. But this is the experiment 1. This is the experiment 2. Then by taking this we got third one. Then when they combine each other, when nitrogen and oxygen combine, it will produce N2O3. The percentage of nitrogen in N2O3 when direct nitrogen and oxygen combine, the percent of nitrogen is 36.8. Nitrogen percentage is 36.85, and oxygen percentage is remaining 100 minus this, the result is 63.15. 63.15. This is the percent oxygen, nitrogen. Now you calculate NO ratio. NO ratio in this combination is 36.85 upon 63.15. What is the value? The value is 1.172. Same value, 1.172. So previously it was obtained 1.171. It becomes how much? 1.172. And this much. This much. So these two is almost same. That means this law, this data indicate it is same. The law states that either same or simple multiple. In the example we got simple multiple, but in the problem we got same. Either same or simple multiple. When you compare the ratio of elements, different elements combined with the fixed mass of other, the value will be that value you will get. Then compare this value with the when they combine each other. Nitrogen and oxygen when combined produce N2O3. What is the percent nitrogen and oxygen? Or what is the ratio of nitrogen and oxygen? 1.172. That means this data is same. That means satisfying the law. Either same or simple multiple. So this is regarding the fourth law. So that is fifth law, last law regarding law of conservation. Last law regarding conservation, law of chemical combination is fifth law. Fifth law is called Gay-Lussac law of gaseous volume. Gay-Lussac law of gaseous volume. That means this law is applicable only for gaseous reactant, and the reactant should be in gaseous state and product will be also gaseous state. This law is applicable when both reactant and product are in gaseous state. What is the law? The law states that ratio of the volume of the reactants, gaseous reactants, ratio of the volume of the gaseous reactants and gaseous products. Ratio of the volume of the gaseous reactants and gaseous products will be simple ratio under constant temperature and pressure. This is the condition. What is the condition? The pressure temperature should be constant and the volume of the reactants will compare with the volume of the product. Volume of reactant and volume of product will be compared, taking constant temperature pressure. This ratio will be a simple ratio. For example, you take hydrogen gas burn in presence of oxygen gas, on heating produce steam. Steam is also gas. You balance it. This is the actual balance equation. 2H2G plus O2G producing 2H2OG. If temperature and pressure is constant, you have to remember, we will discuss later. When temperature, pressure is constant, equal volume contains equal mole of gas. Equal volume contains equal number of molecules. When temperature, pressure is constant, same volume of gas contains same number of particles. Here number of particles 2, here number of particles 1, here number of particles 2. Let it be, if it is 1V, if the volume is 1V, let it be 1V. It will be 2V because 2 times. As per the law, when temperature, pressure is constant, equal volume contains equal number of molecules. Here 1 molecule, let volume is 1V. Here 2 molecule, 2 multiplied, 2 volume. Here in the product, 2 water means 2 volume. Number of water 2, twice. So volume will be 2V. Number of oxygen is 1. Oxygen molecule is 1. So 1V. Here hydrogen molecule is 2. That value is multiplied, that is the volume. Here 2 volume, here 1 volume, here 2 volume. Because condition is temperature, pressure is constant. When temperature, pressure will be constant, equal molecule contains equal volume. Here 2 molecule 2V, 1 molecule 1V, 2 molecule 2V. Then what is the ratio? The ratio is here 2:1. Then when take the product is to 2. This is the for reactant 2:1 and product is 2. So 2:1 is to 2. Just like a simple. If you take 2:1 is a simple and 1:2 is also simple. That's why it is satisfied the law of Gay-Lussac law of gaseous volume. If you take another example, nitrogen, 3 hydrogen producing 2 ammonia, all in gaseous state. Then what will be the volume? What will be the volume? What is the volume ratio? It will be 1V, it will be 3V, it will be 2V, because as per the number of molecule. What is the ratio? 1:3:2. 1:3 is a simple ratio. 3:2 is a simple ratio. That's why mole is a simple ratio, satisfying the Gay-Lussac law of gaseous volume. These are the 5 important laws of chemical combination. All reactions, maybe physical change or maybe a chemical change, all changes follow these 5 laws. Law of conservation, that is law of chemical combination. Thank you.